Welcome to part two of our gas laws. So we're going to learn a few more equations today, and then these will be it for our gas instructions. So we're going to go through notes today, a few example problems, and then I'm also going to do a few questions on your worksheet. So the first thing that we're going to be starting with is Avogadro's law. And this does come back from Amiado Avogadro, the inventor of the mole. When he discovered the mole, he was working with gases, and that's where he came up with Avogadro's number. So he found that for a confined gas or a gas that's trapped, the volume and the number of moles are directly proportional if pressure and temperature remain constant. So his equation is V1 over N1 equals V2 over N2, and N is going to be number of moles. So yet again, you need to be able to reorganize this equation to solve for N2 or V2. V2, if you want to write this down, is going to be equal to V1 times N2 over N1. N2 is going to be equal to N1 times V2 over V1. So those are two other equations that you could have written on your notes to help you out with Avogadro's law. The next law that we're going to learn is the ideal gas law. The ideal gas law is a relationship between pressure, volume, temperature, and number of moles of a gas. The equation is PV equals nRT. There is a new unit in there, and that new unit is R. So R is our new unit. And R is an ideal gas constant. We have two different things that we can use. We can use for R 0.08206, and we use that when our pressure is an ATM. So when pressure is an ATM, we're going to use this 0.082, truthfully 0.0821. Now, for some reason, our pressure is in kPa, we're going to use this other factor for R. So the number that we're going to use for R, this point in our equation, is going to depend on what unit our pressure is in. Now, if you look at all of the other units for both of these things, obviously N is going to be our moles. You can see that temperature has to be in Kelvin. So for both of these, we've got temperature in Kelvin. So when you set these up, your temperature has to be in Kelvin. And our volume has to be in liters. So we have to make sure our volume's in liters, our temperature is in Kelvin, and our pressure is either in ATM or kPa. If it's an ATM, we're going to use 0.0821 as our R value. If our pressure is in kPa, we're going to use 8.314 as our R value. So I'm going to go ahead and switch over to my camera here, and I'm going to show you guys an example of this problem. So I'm going to go ahead and zoom in a little bit here. We've got this problem here. It says methane, CH4, is being considered for use as an alternative automotive fuel to replace gasoline. 1 gallon of gasoline could be replaced by 655 grams of CH4. What is the volume of this much methane at 25 degrees Celsius and 745 torr? So the first thing that I give to you is I give you kind of steps on how to go ahead and actually do this problem. So our formula is PV equals nRT. The first thing that you're going to want to do is you want to figure out what exactly is the question asking for. And the question is asking for volume. So we're going to solve for volume. So we want to get volume by itself. And that's pretty easy. Volume is equal to nRT divided by pressure. We've got grams of CH4. N is moles. So remember, N is moles. So if I have grams, I can get moles by taking 655 grams and dividing it by the molar mass of methane. So we've got 12.01 is my molar mass for carbon, 1.01 is my molar mass for hydrogen. I've got 4 hydrogens. So 4 times 1.01 plus 12.01 gives us 16.05 as our molar mass for methane. So I'm going to take 655 and divide that by 16.05. That's going to give me moles. So this N is going to equal 40.81 moles. So I've got my N. Torr is going to be my pressure. and 25 degrees Celsius is my temperature. Now, this next step, we need to convert to the right units. We already did that for N, so we've got N, and we converted to the right units by taking 655 over 16.05, and that gave us 40.81 moles. Temperature needs to be in Kelvin. So we're going to take 25 degrees Celsius, and we are going to add 273 to get Kelvin. All right. So 25 degrees Celsius plus 273 gives us 298 Kelvin. And our last option, we've got 745 torr as our pressure. Now on the last page, or on the last slide, I told you that our pressure can either be, we have two options. Pressure can be ATM or KPA.
Misty, can you put me in the elevator early?
So 75 torr, and I have the option of going to either KPA or ATM. So in order to do that, you are going to need your pressure conversion chart. I'm going to pick ATM. I just like ATM better than KPA, but if you choose KPA, that's fine. So to convert torr to ATM, I'm just going to divide by 760. So I'm going to take 745 torr, and I'm going to divide by 760 torr. And that's going to give me my ATM. So 745 divided by 760 is going to give me 0.98 ATM. So now I'm in all of the units I want. So temperature has to be in Kelvin. N has to be moles. And pressure has to be ATM or KPA. Now that I've done my conversions, I need to pick what R value I want to use. So we had two R values. Our first R value that we had, which was on our previous page, was 0.08. We're just going to say 0.0821. And that was when we're working with ATM. Our other R value was 8.314, and that was when we're working with KPA. We are working with ATM, so we are going to use the R value of 0.0821. So the next thing that we need to do is we just need to plug and chug. We're going to plug these numbers into this equation. So V is equal to N. N is 40.81 moles times R. My R value is 0.821. And I'm going to show you how you would write this with our units. So I'm going to go back to my other screen here just for a second to go ahead and show you our values or our units for R. So R is going to be liters over ATM times mole per Kelvin. So we're going to write liters times ATM over mole times Kelvin. Next, we have temperature. Our temperature is 298 Kelvin. And on the bottom, we've got our pressure, and our pressure for this one is going to be 0.98 ATM. So let me show you how all of this is going to cancel out with our R value. So we're going to have moles cancel out. So mole will cancel out with the mole that's underneath on that unit. ATM up top is going to cancel out with this ATM down below. And Kelvin is going to cancel out with Kelvin, leaving us with the unit of liters, which is the unit we want for volume. So in our calculator, 40.81 times 0.821 times 298 divided by 0.98 will give us our answer. So I'm going to go ahead and start typing that in. And I get an answer of 10188.26. Our unit is going to be liters. So that is how many liters that gas would take up. Let's look at our practice problem. So this practice problem says calculate the pressure in bar of 2,520 moles of hydrogen gas stored at 27 degrees Celsius in an 18-liter storage tank. So we've got moles, temperature, and volume. We're trying to solve for pressure. So pressure is what we're going to solve for, and it wants pressure in bar. So we've got N, we've got temp, and we've got volume. We are solving for P. Wants pressure in bar, so you could use either P value you'd like, kPa, or the K value for kPa or the K value for ATM. I'm going to use the value for kPa just as an example here for you guys. So we need to rearrange our equation. Remember, our equation is PV equals nRT. So the first thing we want to do is rearrange that equation. So we're trying to solve for pressure. So pressure is going to be equal to nRT over volume. We have our N. We're going to use our 8.314 for our R value because we're going to try to get our pressure in kPa. Volume right now is in liters, so we're good with volume being in liters. The last thing that we need to convert is our temperature. We need to convert our temperature to degrees or to Kelvin. So 273 plus 27 is going to give us 300 Kelvin. So this equals 300 K. So I'm going to go ahead and start plugging this into my equation. So pressure is equal to number of moles, so 2,520 moles, times our R value is going to be 8.314. It's going to be liters times kPa over moles times Kelvin. So the R value is always volume pressure over mole temperature. The only thing that's ever going to change is just either your kPa or ATM and obviously your front number. And then lastly, we have our temperature of 300 Kelvin. Just to start, moles cancels out, Kelvin cancels out. So we're left with liters and kPa. We want to get rid of that liters. So the last thing that goes underneath is our volume, 180 liters. Liters is going to then cancel out, and we're left with the unit kPa, which is a unit for pressure, which means we set up our equation correctly. The last thing we're going to do is just type this into our calculator. So 2,520 times 8.314 times 300 divided by 180 gives us 34918. So 34918.8 are units kPa. Now the equation asks for pressure in bar, so we're going to convert from kPa to bar. We're going to have to use our conversion chart in order to do this. So I'm starting in kPa. To get to bar, I need PA. So I'm going to convert from kPa to PA and then PA to bar. So I'm going to do that equation, that little calculation down here. So 34918.8 kPa. I'm going to convert that to pascals. That way my kPa can cancel out. And then my last conversion is going to be to bar. And that's 100,000 pascals down below. So 34918 times 1,000 divided by 100,000 gives me 349.19 bar. And that is your final answer. All right, I'm going to switch back to the view for the PowerPoint. All right, the last gas law that we're going to learn is called the combined gas law. So this combines Gay-Lussac's, Boyle's, and Charles's law all into one. When you're working with this one, it's best for your units to be in ATM, liters, and Kelvin. It just happens to make everything work out a little bit better. But if they're not in ATM, liters, and Kelvin, as long as all of your units are the same, then you should be fine. Your temperature always has to be in Kelvin, but let's say they gave you a pressure in torr, you'd need your other pressure to be in torr as well for this to work out. If they gave you one volume in milliliters and one volume in liters, you'd need to make sure that both of them are either in milliliters or both of them are in liters. So you just need to make sure that your units, your similar units, are the exact same. So this is our equation. Obviously, solving for one variable of these is going to be a little bit more work, but you're going to be cross multiplying and dividing to isolate one unit individually. So I'm going to go ahead and switch over to my camera view to go ahead and show you guys how to do some of these problems. All right, so our example problem, it says when filled with air, a typical scuba tank with a volume of 13.2 liters has a pressure of 153 atm. The water temperature is 27 degrees Celsius. How many liters of air will be provided to the diver's lungs at a depth of 70 feet in the ocean where the pressure is 3.13 atm? We're also going to add to this, because I forgot, that the temperature drops to 25 degrees Celsius. Okay, so we're going to have a temperature drop at 25 degrees Celsius as well. All right. So we've got a volume 1, a pressure 1, a temperature 1. Wants to know liters, so we're solving for V2. And it gives us a temp 2 and a pressure 2. The first thing that you need to do is make sure that everything is in similar units. So both of our pressures are in ATM, so that's good. And our temperatures are in degrees Celsius, and we need to convert those to Kelvin. And lastly, our volume is in liters, and that's what our question's asking for. So the next thing that we need to do is convert all of our temperatures over to Kelvin. So 27 plus 273 is going to equal 300 Kelvin. And 25 plus 273 is going to equal 298 Kelvin. So we are working with this equation, P1 V1 over T1 equals P2 V2 over T2. We're solving for V2. So the first thing I need to do is cross multiply. So I'm going to have P1 V1 T2 is equal to P2 V2 T1. And lastly, I want to isolate V2, so I'm going to divide by P2 T1. So volume 2 is equal to P1 V1 T2 over P2 times T1. Next step is just plug and chug. So pressure 1 is 153 atm. Volume 1 is 13.2 liters. Temperature 2 is 298 Kelvin. Pressure 2 is 3.13 atm. And temperature 1 is 300 Kelvin. Looking at my units, ATM can cancel out, Kelvin can cancel out, and I'm left with the unit liters. Next, I just have to type this into my calculator. So 153 times 13.2 times 298 divided by 3.13 times 300. And that gives me 640.94. And your unit's going to be liters. Looking at our next one on your sheet, it's a practice problem. So I'm going to help you with the setup of this, and then we'll pause the video and give you an opportunity to go ahead and try it. So it says a sample of ammonia is found to occupy 0.25 liters under laboratory conditions of 27 degrees Celsius and 0.85 ATM. Wants us to find the volume at 0 degrees Celsius and 1 ATM. So we're solving for volume. You've got V1, T1, P1, T2, and P2, and you are obviously solving for V2. And remember, your equation is so I'll go ahead and pause the video and allow you to solve for it. Okay, so let's go ahead and solve for V2. So V2, when you rearrange your equation, is going to be equal to P1, V1, T2 over P2 times T1. We need to make sure everything's in the right unit. So I've got ATM and ATM. That's good. I've got to convert these degrees Celsius. So this is going to be 273 Kelvin. And this one's going to be 300 Kelvin. And my volume's in liters. So pressure 1 is 0.85 ATM times volume 1, 0.25 liters, times temperature 2, which is 273 Kelvin, over pressure 2, which is 1 ATM, times my first temperature, which is 300 Kelvin. ATM can cancel out, Kelvin can cancel out, and I'm left with a unit liters. I just have to type it into my calculator and then we can go. So 0.85 times 0.25 times 273 divided by 300 gives us 0.19 liters as our final answer. So next I wanted you guys to go ahead and get your worksheet in front of you, your worksheet that we were working on last week with our gas laws. So you should already have pages 1 through 3 completed. You guys are going to be working on pages 4 and 5 now. So page 4 is all combined gas law. So all of these are going to be the second thing that we learned today. So page 4 is all combined gas law. It does give you a different equation up here too for the combined gas law. So it also gives you this V1, P1, N1, T1. So I actually wanted to show you guys how to use that. So we're going to do question number 5 together just to show you guys how to actually use that equation there. So we're going to look at number 5 really quick because this one's working with moles. So just to kind of help you out on number 5. So number 5 throws some words like moles at you, which should not scare you because we've already learned what moles are. But we've got 4.5 moles of gas, 55 milliliters, 5 degrees Celsius, 1 ATM, 10.5 moles, 27 degrees Celsius, and 1.25 ATM. So we've got a lot of information thrown at us. I'm going to go ahead and kind of write what everything is. So this is going to be N1. This is going to be V1, T1, P1, N2, T2, and P2, and we are obviously solving for V2. So that's what we're going to solve for is V2. So the equation that you're going to work with is V1, P1 over N1, T1 is equal to V2, P2 over N2, T2. We're solving for V2. So if we rearrange this, we're going to cross multiply everything. How it's going to end up looking afterwards is V2 is going to be equal to V1, P1, N2, T2, all on top of N1, T1, P2. So that's our very big problem. We need to make sure everything's in similar units. So I've got ATM and ATM. I've got milliliters. I'm solving for volume, so I'm going to be using milliliters there. Moles and moles. And lastly, I have my degrees Celsius and degrees Celsius that I need to convert to Kelvin. So 27 degrees Celsius is going to be 300 Kelvin. And 5 degrees Celsius is going to be 278 Kelvin. So the next step is honestly just plugging and chugging. So volume 1 is 550 milliliters. times pressure 1, which is 1 atm, times N2, which is 10.5 moles, times temperature 2, which is 300 Kelvin, divided by N1, which is 4.5 moles, times T1, which is 278 Kelvin, times pressure 2, which is 1.25 atm. We're going to cancel out like units, so atm cancels out with this atm, moles cancel out with moles, and Kelvin cancels out with Kelvin, leaving us with milliliters. The last step, obviously, is going to be plugging this into our calculator. So 550 times 10.5 times 300 divided by 4.5 times 278 times 1.25 gives us a final answer of 1383.51, and your unit is going to be milliliters. For your ideal gas laws on this worksheet, it tells you that your R is going to be 0.821, and it wants your pressure in ATM and your unit to be temperature to Kelvin, volume is in liters, and N is moles. In the event that you need the other R value, the other R is going to be 8.314. And remember, that's when we work with kPa, so that's going to be up top, kPa times liters over moles times Kelvin. So if you need that one, that's on there too. So what you're going to work on for the remainder of today is 1 through 5 for the combined gas law, and then 1 through 7 for the ideal gas law. So you're going to go ahead and work on these, and then we will be kind of going over some of these tomorrow in class.